Proceed to question number 463. Question number 463. A mobile payments API receives short validation requests, then submits accepted transactions to a long-running backend whose CPU and memory settings change over time. The company wants managed services and does not want to operate servers or Kubernetes worker nodes. Which architecture has the least operational overhead? Option A, receive requests through API gateway and step functions, then run the backend on EKS with self-managed nodes. Option B, use an event bridge rule and SQS, then operate the backend on an EKS anywhere standalone cluster. Option C, use event bridge and SQS, then run the backend on an EC2 spot fleet. Option D, receive requests through API gateway, validate them with Lambda, and run the backend as an ECS service on AWS Fargate. The required response is D, receive requests through API gateway, validate them with Lambda, and run the backend as an ECS service on AWS Fargate. API gateway and Lambda handle short request validation without servers. ECS on Fargate supports adjustable long-running containers while removing host provisioning and patching. The incorrect choices fail for the following reasons. A. Self-managed EKS nodes require instance and cluster capacity administration. B. EKS Anywhere requires the company to operate on-premises or edge Kubernetes infrastructure. C. A spot fleet introduces instance operations and interruption handling for the backend. Use Lambda for short event-driven work and Fargate for managed long-running containers. Question number 464. Question number 464. A retailer stores raw data in an S3 lake. Every night, the company must run serverless ETL and load the results into an MPP warehouse. Analysts must train machine learning models from SQL without managing separate ML infrastructure. Which solution meets all requirements? Option A. Use AWS Glue for ETL, load Aurora serverless, and use Aurora ML. Option B. Use EMR clusters for ETL, load provisioned Amazon Redshift, and use Redshift ML. Option C. Use AWS Glue for ETL, load Amazon Redshift serverless, and create models with Amazon Redshift ML. Option D. Use AWS Glue for ETL, create Athena tables, and train models with an Athena ML feature. In this case, select C. Use AWS Glue for ETL, load Amazon Redshift serverless, and create models with Amazon Redshift ML. The key reason is AWS Glue provides serverless ETL, Redshift serverless supplies MPP warehousing, and Redshift ML allows model creation and training through SQL. The remaining options are incorrect because A. Aurora is a relational operational database and is not an MPP data warehouse. B. The analytics services fit, but running EMR clusters adds avoidable infrastructure management. D. Athena is a serverless query service rather than the requested warehouse, and it does not provide the described model training feature. A useful examination rule is this. Pair AWS Glue with Redshift serverless when serverless ETL, MPP analytics, and SQL-based ML are required. Review question number 465 carefully. Question number 465. A biotechnology company wants to run Kubernetes workloads with Amazon EKS capabilities inside its own facility. Regulatory policy requires application data and the Kubernetes control plane to remain at that physical site. Which deployment option should the company select? Option A. Use an AWS Snowmobile as an on-premises compute platform. Option B. Request an AWS local zone to be installed inside the facility. Option C. Install an AWS Outposts rack and deploy an EKS local cluster at the facility. Option D. Operate the workloads on a Snowball Edge Storage optimized device as the permanent EKS platform. The best answer is C. Install an AWS Outposts rack and deploy an EKS local cluster at the facility. This is correct because an Outposts rack supports EKS local clusters whose control plane and worker resources run on premises, allowing workloads and required data to remain at the site. The alternatives can be eliminated because a snowmobile is designed for large-scale data transfer, not managed Kubernetes hosting. B. Local zones are AWS-operated infrastructure locations and are not installed as customer-owned data center equipment. D. Snowball Edge is not the full EKS local cluster architecture provided by Outposts. Remember this distinction for the exam. Use EKS local clusters on Outposts when Kubernetes control plane and workload data must stay on premises. Now consider question number 466. Question number 466. A video analytics company currently stores a rapidly growing dataset on an on-premises NFS server. Existing applications must continue using an NFS file interface after migration, but the company wants the scale and storage tier economics of Amazon S3. Which solution is most cost-effective? Option A. Deploy a volume gateway and apply S3 lifecycle rules to its backing storage. Option B. Move the data to EFS1 Zone IA and enable an EFS lifecycle policy. Option C. Deploy an Amazon S3 file gateway and use S3 lifecycle rules to transition older objects to lower-cost storage classes. Option D. Move the data to EFS standard IA and enable an EFS lifecycle policy. The correct answer is C. Deploy an Amazon S3 file gateway and use S3 lifecycle rules to transition older objects to lower-cost storage classes. Here is the technical justification. S3 file gateway preserves NFS access for applications while storing files as S3 objects. S3 lifecycle policies can then move colder objects through lower-cost tiers. Now consider why the remaining options are unsuitable. A. Volume gateway exposes ISCSI block storage rather than the required NFS file interface. B. One Zone IA reduces availability and still does not provide the same breadth of S3 lifecycle tiers. D. EFS supports NFS, but S3-backed storage with lifecycle tiers is generally more cost-efficient for a large repository. Keep this examination point in mind. Use S3 file gateway when applications must retain NFS or SMB access, while data is stored economically in S3. The next item is question number 467. Question number 467. A data buyer must privately consume a custom database application running on EC2 instances in a supplier's AWS account. The buyer's VPC has no Internet Gateway, VPN, or Direct Connect connection, and the supplier wants to expose only the database service rather than provide full network connectivity. Which solution is the best fit? Option A. Attach both VPCs to a transit gateway and also configure VPC peering. Option B. Provision a hosted Direct Connect connection and then create VPC peering. Option C. Have the supplier place a network load balancer in front of the EC2 instances and publish it through an AWS private link endpoint service. Option D. Create a client VPN between the two VPCs and also establish VPC peering. The appropriate choice is C. Have the supplier place a network load balancer in front of the EC2 instances and publish it through an AWS private link endpoint service. The reasoning is as follows. AWS Private Link is designed to expose a specific provider service privately to consumer VPCs through interface endpoints without requiring internet access or broad routed connectivity. The other choices do not satisfy the requirement because A. Transit gateway and VPC peering are alternative routing approaches and do not need to be combined. B. Direct Connect is unnecessary for this AWS to AWS use case, while peering would already provide network routing. D. Client VPN serves remote clients, and combining it with peering is not the correct VPC to VPC service consumption design. The key takeaway is use private link when a provider should expose one private service without sharing full VPC connectivity. Let us work through question number 468. Question number 468. A data engineering team receives Parquet files in an S3 lake and must let business analysts clean anomalies, standardize timestamps, profile datasets, and reuse the same preparation steps across departments. The company wants a visual, no-code service with reusable transformation definitions and lineage information. Which solution meets the requirements? Option A. Create Athena SQL statements for each transformation and share the queries. Option B. Use AWS Glue Data Brew projects and share the preparation logic as Data Brew recipes. Option C. Run Spark transformations with EMR serverless and distribute the job scripts. Option D. Build transformations in AWS Glue Studio Visual Jobs and use the job definitions as the collaboration mechanism. The appropriate choice is B. Use AWS Glue Data Brew projects and share the preparation logic as Data Brew recipes. The requirement is satisfied because Data Brew is purpose-built for visual, no-code data preparation and profiling. Recipes capture repeatable transformation steps that can be reused in managed jobs. A. Athena SQL requires query authoring and does not provide the requested visual recipe experience. C. EMR serverless still requires Spark or Hive job development. D. Glue Studio is visual but is centered on ETL job authoring rather than the same no-code recipe and profiling workflow. Exam tip. Use Data Brew for reusable no-code data cleansing, profiling, and recipe-based preparation. Now consider question number 469. Question number 469. A logistics company is moving an on-premises Kubernetes application to AWS. The application already communicates with its broker by using EMQP, and the company wants to minimize both application changes and messaging infrastructure administration. Which architecture should be selected? Option A. Rewrite the application as Lambda functions and replace EMQP with Amazon SQS. Option B. Migrate the containers to Amazon ECS and replace EMQP with Amazon SQS. Option C. Migrate the containers to Amazon EKS and use Amazon MQ as the managed message broker. Option D. Run the application on highly available EC2 instances and use Amazon MQ. The required response is C. Migrate the containers to Amazon EKS and use Amazon MQ as the managed message broker. Amazon EKS preserves the Kubernetes operating model, while Amazon MQ supplies a managed broker that supports AMQP. This combination avoids protocol rewrites and reduces broker administration. The incorrect choices fail for the following reasons. A. This option requires both a compute model rewrite and a messaging protocol change. B. SQS does not expose the existing EMQP broker interface, so application changes would be required. D. Amazon MQ fits the protocol, but self-managed EC2 application capacity creates more operational overhead than EKS. Use Amazon MQ when migrating applications that depend on standard broker protocols such as EMQP. Apply precise reasoning to question number 470. Question number 470. A multiplayer service runs EC2 fleets behind network load balancers in several AWS regions. Global users experience variable latency because requests traverse unpredictable internet routes. The company wants to retain the regional NLB architecture while improving end-to-end network performance. Which solution should be implemented? Option A. Create an AWS Global Accelerator Standard Accelerator and configure the existing regional NLBs as endpoints. Option B. Create an equally weighted Route 53 record for all regional NLBs. Option C. Add more regions and duplicate the EC2 and NLB stacks without changing traffic routing. Option D. Replace every NLB with an application load balancer. In this case, select A. Create an AWS Global Accelerator Standard Accelerator and configure the existing regional NLBs as endpoints. The key reason is Global Accelerator provides static anycast entry points and carries traffic across the AWS global network to a healthy regional NLB, reducing internet path variability without replacing the existing endpoints. The remaining options are incorrect because B. Weighted routing distributes DNS responses but does not direct traffic over the AWS global network or choose the lowest latency healthy endpoint. C. Additional regions alone do not solve inefficient routing to the existing deployments. D. Changing load balancer type does not itself optimize global network routing. A useful examination rule is this. Use Global Accelerator for global, non-cacheable traffic that benefits from AWS backbone routing and static anycast IPs. Let us focus on question number 471. Question number 471. A treasury platform is moving vendor file intake to Amazon S3. Modern partners can use S3 APIs, but several legacy partners can upload only through SFTP. The company wants a managed bridge to S3 and does not want to operate an SFTP server. Which solution has the least operational overhead? Option A. Use AWS DMS to replicate each partner's file system to S3. Option B. Run an SFTP daemon on an EC2 instance and copy uploaded files to S3. Option C. Create an AWS transfer family SFTP endpoint backed by the S3 bucket. Option D. Expose an SMB share from an S3 file gateway to the external partners. The best answer is C. Create an AWS transfer family SFTP endpoint backed by the S3 bucket. This is correct because AWS transfer family provides managed SFTP endpoints with S3 storage integration, allowing legacy clients to continue using SFTP without server administration. The alternatives can be eliminated because A. AWS DMS migrates supported databases and is not an SFTP file ingestion service. B. The company would need to patch, scale, secure, and make the EC2-based SFTP server highly available. D. An SMB file share does not satisfy clients that require SFTP. Remember this distinction for the exam. Use AWS transfer family to expose managed SFTP, FTPS, or FTP access backed by S3 or EFS. Let us examine question number 472. Question number 472. A public relations team has 5 years of scanned PDF articles. Text must first be extracted with Amazon Textract, then analyzed for entities, key phrases, and sentiment with the smallest amount of custom ML work. What should the company do with the Textract output? Option A. Query the extracted text with Athena and treat the query output as sentiment analysis. Option B. Store the text in DynamoDB and train a sentiment model in SageMaker. Option C. Send the extracted text to Amazon Comprehend and store the analysis results in Amazon S3. Option D. Load the text into QuickSight and use dashboards to infer sentiment. The correct answer is C. Send the extracted text to Amazon Comprehend and store the analysis results in Amazon S3. Here is the technical justification. Amazon Comprehend provides managed natural language analysis for sentiment, entities, and key phrases. It can consume the text extracted by Textract without requiring the team to build a custom model. Now consider why the remaining options are unsuitable. A. Athena can query structured data, but does not perform the requested NLP analysis by itself. B. This approach requires ML model development and ongoing model operations. D. QuickSight visualizes data, but is not the service that extracts sentiment and language entities. Keep this examination point in mind. Combine Textract for document text extraction with Comprehend for managed NLP analysis. Question number 473. Highlights an important distinction. Question number 473. A telemetry application running across multiple availability zones must accept a continuous real-time feed from external producers and retain the unmodified records in Amazon S3. The company wants scalable ingestion plus managed buffering and delivery. Which design meets the requirement? Option A. Install datasync agents on the EC2 instances and schedule frequent transfers to S3. Option B. Ingest records with Kinesis data streams and configure Amazon Data Firehose to consume the stream and deliver to S3. Option C. Use AWS DMS with the EC2 instances as source endpoints and S3 as the target. Option D. Create direct connect and send direct put requests to Data Firehose before delivery to S3. The appropriate choice is B. Ingest records with Kinesis data streams and configure Amazon Data Firehose to consume the stream and deliver to S3. The reasoning is as follows. Kinesis Data Streams accepts scalable real-time producer traffic, and Data Firehose provides managed buffering, batching, and delivery into the S3 destination. The other choices do not satisfy the requirement because a data sync is designed for file and object transfer, not continuous real-time event ingestion. C. AWS DMS replicates supported data stores and cannot treat arbitrary EC2 application instances as database source endpoints. D. Direct Connect is unrelated to the stated ingestion need and adds unnecessary infrastructure. The key takeaway is use Kinesis data streams for real-time ingestion and Data Firehose for managed delivery to destinations such as S3. Question number 474. Question number 474. A company is replacing hundreds of on-premises cron jobs. Each job already runs well in a container and lasts between 1 and 20 minutes. Jobs have different recurring schedules, and some must also be launched once at a specified future time. The company wants minimal refactoring and no server management. Which solution is the best fit? Option A. Convert every job to Lambda and invoke the functions from EventBridge Scheduler. Option B. Use Amazon EventBridge Scheduler for recurring and one-time schedules, and launch each container task on AWS Fargate. Option C. Build a step functions workflow with long wait states for every execution and use Fargate run task. Option D. Run the containers in AWS batch and rely only on batch scheduling policies. The best answer is B. Use Amazon EventBridge Scheduler for recurring and one-time schedules, and launch each container task on AWS Fargate. The requirement is satisfied because EventBridge Scheduler supports cron, rate, and one-time future schedules. Fargate runs the existing containers without managing hosts and supports the stated job duration. A. Lambda would require refactoring and is a poorer fit for preserving arbitrary existing container jobs. C. Step functions can wait and invoke tasks, but maintaining a workflow execution per schedule adds unnecessary orchestration. D. AWS batch scheduling policies do not replace the broad recurring and one-time scheduling capability described. Exam tip. Use EventBridge Scheduler for recurring or one-time invocation and Fargate for serverless container jobs. Question number 475. Requires careful analysis. Question number 475. An IoT aggregation service uses DynamoDB for metadata lookups, but some incoming payloads are already 700 kilobytes and will continue growing. The company wants an operationally simple pattern that preserves DynamoDB as the primary index. Which solution should be used? Option A. Compress every payload with Lambda and write the result directly into DynamoDB. Option B. Split every payload into multiple items with one partition key and write them with batch write item. Option C. Store each large payload in S3 and save its object URL or key in the corresponding DynamoDB item. Option D. Send oversized payloads to Amazon Document DB through a filtering Lambda function. The required response is C. Store each large payload in S3 and save its object URL or key in the corresponding DynamoDB item. DynamoDB items are limited to 400 kilobytes. Storing the payload in S3 and retaining a small pointer and metadata item in DynamoDB avoids the limit and scales with growing objects. The incorrect choices fail for the following reasons. A. Compression cannot guarantee that every current or future payload will remain under the item limit. B. Chunking increases read, write, consistency, and reassembly complexity, and batch write item is not atomic across the collection. D. Adding document DB and custom routing creates another database and more operational overhead than the S3 pointer pattern. Store oversized objects in S3 and keep metadata plus an object reference in DynamoDB. The next key item is question number 476. Question number 476. A consumer application will support millions of users. Sign-ins from an unfamiliar device, IP address, or geographic location must trigger stronger verification, while ordinary sign-ins should remain streamlined. Which authentication service and feature meet the requirement? Option A. Use a Cognito identity pool and enable MFA on federated AWS credentials. Option B. Use IAM Identity Center permission sets and require MFA for the consumer population. Option C. Use an Amazon Cognito user pool with risk-based adaptive authentication and MFA. Option D. Create IAM users for all customers and allow each user to manage an MFA device. In this case, select C. Use an Amazon Cognito user pool with risk-based adaptive authentication and MFA. The key reason is Cognito user pools are designed for large application user populations. Adaptive authentication evaluates contextual risk signals and can require MFA when a sign-in is suspicious. The remaining options are incorrect because A. Identity pools primarily provide temporary AWS credentials and are not the user directory feature for adaptive sign-in risk controls. B. IAM Identity Center is intended for workforce access rather than large-scale consumer authentication. D. IAM users are not appropriate for millions of application customers. A useful examination rule is this. Use Cognito user pools and adaptive authentication for risk-based MFA in consumer applications. We will now analyze question number 477. Question number 477. An ECS platform uses container images that must be checked for known CVs. The company wants current images and all newly pushed images scanned while making the fewest changes to the existing ECS workloads. Which solution should be selected? Option A. Move the workloads to EKS and enable EC or enhanced scanning. Option B. Store images as versioned S3 objects and invoke Lambda to request inspector scans. Option C. Store images in S3 and use Amazon May-C to inspect them after each upload. Option D. Store the images in private Amazon EC/R repositories and configure basic scan-on-push filters for the matching repositories. The correct answer is D. Store the images in private Amazon EC/R repositories and configure basic scan-on-push filters for the matching repositories. This is correct because Amazon EC/R integrates directly with ECS image references and supports managed vulnerability scanning. Migrating images into repositories configured for scan-on-push scans new pushes without changing the orchestrator. The alternatives can be eliminated because A. Enhanced scanning is capable, but migrating the workloads from ECS to EKS is an unnecessary application platform change. B. Inspector's container image integration is with EC/R, not arbitrary image files in S3. C. May-C discovers sensitive data in S3 objects and is not a container CVE scanner. Remember this distinction for the exam. Use EC/R image scanning for container vulnerabilities. Enhanced scanning adds continuous inspector-based coverage. Proceed to question number 478. Question number 478. During promotions, a queue drives highly concurrent Lambda invocations that perform CPU-intensive processing. The company wants to control concurrency, maintain latency, and lower total compute cost by selecting an efficient memory and CPU allocation. Which configuration is most appropriate? Option A. Set provisioned concurrency and reduce memory for every invocation. Option B. Set reserved concurrency and increase memory according to AWS Compute Optimizer recommendations. Option C. Set provisioned concurrency and increase memory according to Compute Optimizer recommendations. Option D. Set reserved concurrency and reduce memory for every invocation. In this case, select B. Set reserved concurrency and increase memory according to AWS Compute Optimizer recommendations. Here is the technical justification. Reserved concurrency controls and protects function capacity without the additional charge associated with provisioned concurrency. Increasing memory also increases CPU, and Compute Optimizer recommendations can reduce duration and overall cost for CPU-bound work. Now consider why the remaining options are unsuitable. A. This combines the added cost of provisioned concurrency with a memory reduction that can hurt CPU-bound performance. C. Provisioned concurrency reduces cold start latency, but introduces additional cost that is not required by the stated queue processing workload. D. Reducing memory also reduces CPU and can lengthen CPU-intensive executions, potentially increasing latency and cost. Keep this examination point in mind. Right-size Lambda memory for CPU-bound code because memory allocation also determines CPU capacity. Let us work through question number 479. Question number 479. A nightly AWS batch workflow must call a SAA-C reporting endpoint only after the job enters the succeeded state. The endpoint is HTTPS and uses a username and password. The company wants a serverless integration with no custom polling code. Which solution meets the requirement? Option A. Have the batch job published directly to API Gateway and configure an HTTP proxy to the SAA-C API. Option B. Have the batch job call API Gateway, which invokes Lambda to call the SAA-C endpoint. Option C. Match AWS batch succeeded events with an event bridge rule and invoke an event bridge API destination that uses a managed authenticated connection. Option D. Use Event Bridge Scheduler to detect batch state changes and invoke a Lambda function. The appropriate choice is C. Match AWS batch succeeded events with an Event Bridge rule and invoke an Event Bridge API destination that uses a managed authenticated connection. The reasoning is as follows. AWS batch publishes job state change events to Event Bridge. An API destination can call the external HTTPS endpoint, while an Event Bridge connection securely manages the authentication values. The other choices do not satisfy the requirement because A. This requires the job to implement notification logic and does not use the native state event. B. The extra API gateway and Lambda layers add code and components that API destinations avoid. D. Event Bridge Scheduler creates time-based invocations and does not match incoming batch state change events. The key takeaway is use Event Bridge API destinations for authenticated, serverless delivery of AWS events to external HTTPS APIs. Let us examine question number 480. Question number 480. A company will use Amazon Managed Grafana to visualize operational data in a private Amazon RDS database. Database traffic must not traverse the public internet. Which configuration satisfies the requirement? Option A. Configure Grafana for VPC access, but connect it to a public RDS endpoint. Option B. Create a private link interface endpoint for the Grafana control plane API and use it as the database data path. Option C. Leave the workspace outside the VPC and make the RDS instance publicly accessible. Option D. Configure the managed Grafana workspace for VPC access and connect it to the private RDS endpoint through private subnets and security groups. The best answer is D. Configure the managed Grafana workspace for VPC access and connect it to the private RDS endpoint through private subnets and security groups. The requirement is satisfied because managed Grafana VPC access places data source connections in selected private subnets. With appropriate security groups, the workspace can query the private RDS endpoint without public exposure. A. Placing the workspace in a VPC does not make a public database endpoint private. B. A private link endpoint for the Grafana service API does not provide Grafana's outbound connection to an RDS data source. C. A public database endpoint exposes the data path to the internet. Exam tip. Configure managed Grafana VPC access when dashboards must query private data sources. The next item is question number 481. Question number 481. A software company exposes its production portal through an application load balancer, ALB. Separate target groups contain the production fleet and a single pre-release Amazon EC2 instance. The engineering team needs to reach the pre-release instance through dev.portal.example.com. The instance can be replaced at any time, so the DNS configuration must not depend on its IP address. Which architecture will meet these requirements? Option A. Assign an elastic IP address to the pre-release instance and create a Route 53A record for dev.portal.example.com that points to the elastic IP address. Option B. Create a Route 53 alias record for dev.portal.example.com that points to the ALB. Configure the ALB to redirect requests for that hostname to the pre-release instance's public IP address. Option C. Create a Route 53 alias record for dev.portal.example.com that points to the ALB. Add a host header listener rule that forwards matching requests to the target group containing the pre-release instance. Option D, register all production and pre-release instances in one target group. Point dev.portal.example.com to the ALB and forward the host name to that shared target group. The required response is C. Create a Route 53 alias record for dev.portal.example.com that points to the ALB. Add a host header listener rule that forwards matching requests to the target group containing the pre-release instance. The alias record continues to reference the stable ALB endpoint, while the ALB host header rule selects the dedicated target group. Replacing the development instance only requires the target group registration to update. The incorrect choices fail for the following reasons. A. The elastic IP remains stable only if it is explicitly reassociated, which adds instance-specific administration and bypasses the existing load balancer. B. An ALB redirect returns a client-side HTTP response. It does not forward the request to a specific instance address. D. A shared target group would allow development requests to reach production instances. Use ALB host-based routing to direct different DNS names to separate target groups. Now consider question number 482. Question number 482. A ticketing application currently runs its web code and MySQL database on one Amazon EC2 instance. Demand is increasing, and the company wants both the application tier and database tier to scale automatically while remaining highly available. Which solution best meets the requirements? Option A. Run the web tier in an EC2 auto-scaling group across multiple availability zones behind an application load balancer. Use an Amazon Aurora Serverless v2 MySQL-compatible cluster for the database. Option B. Place several EC2 web instances in an ALB target group without an auto-scaling group. Use a multi-instance Amazon RDS for MySQL deployment. Option C. Run the web tier in an EC2 auto-scaling group behind an ALB. Replace MySQL with a multi-node Amazon Redshift cluster. Option D. Place the EC2 instances behind an ALB and use an Amazon Elastic Cache for RedISS cluster as the system of record through a MySQL connector. The correct answer is A. Run the web tier in an EC2 auto-scaling group across multiple availability zones behind an application load balancer. Use an Amazon Aurora Serverless v2 MySQL-compatible cluster for the database. The key reason is the auto-scaling group and ALB provide an elastic, multi-availability zone application tier. Aurora Serverless v2 supplies a managed MySQL-compatible database whose capacity adjusts with workload demand. The remaining options are incorrect because B. The database is managed, but the web tier lacks automatic scaling. C. Amazon Redshift is an analytical warehouse, not a transactional MySQL replacement. D. Elastic Cache is a cache and cannot serve as the durable MySQL database layer. A useful examination rule is this. Combine load-balanced auto-scaling with a managed database that can scale for variable demand. The next item is question number 483. Question number 483. A research organization will store regulated documents in Amazon S3. All new objects must use server-side encryption, and the cryptographic key must rotate automatically every 12 months. The operations team wants to avoid a manual rotation process. Which solution has the least operational overhead? Option A. Use SAA-C03 as the bucket's default encryption and configure an annual customer rotation schedule for the S3 managed key. Option B. Create a customer-managed AWS KMS key that uses imported key material, enable automatic rotation, and configure the bucket to use that key. Option C. Create a customer-managed KMS key, configure the bucket for SAA-C and create a yearly runbook to replace the key manually. Option D. Create a customer-managed KMS key with automatic rotation enabled and configure S3 default encryption to use the key before uploading the documents. The appropriate choice is D. create a customer-managed KMS key with automatic rotation enabled and configure S3 default encryption to use the key before uploading the documents. This is correct because a customer-managed KMS key supports automatic rotation and can be selected in the bucket's default SAA-C03 configuration, satisfying the annual rotation requirement without a recurring manual task. The alternatives can be eliminated because SAA-C03 does not expose a customer configurable annual rotation policy. B. Automatic KMS rotation is not supported for keys with imported key material. C. Manual replacement introduces avoidable yearly administration. Remember this distinction for the exam. Use a customer-managed KMS key when the workload requires a defined automatic key rotation policy. Review question number 484. Carefully. Question number 484. An enterprise manages dozens of AWS accounts through AWS organizations. Employees and groups must continue to be administered in the company's self-managed on-premises Microsoft Active Directory, but users need one sign-on experience for all assigned AWS accounts. Which design will meet these requirements? Option A. Create a new AWS-managed Microsoft AD directory and migrate all users and groups into it. Use the new directory as the IAM Identity Center identity source. Option B. Create only a two-way trust between AWS-managed Microsoft AD and the on-premises directory without configuring IAM Identity Center. Option C. Enable IAM Identity Center. Use AWS-managed Microsoft AD as its identity source and establish a two-way forest trust with the self-managed on-premises Active Directory. Option D. Run a custom identity provider on EC2 and connect that provider to IAM Identity Center. In this case, select C. Enable IAM Identity Center. Use AWS-managed Microsoft AD as its identity source and establish a two-way forest trust with the self-managed on-premises Active Directory. Here is the technical justification. IAM Identity Center supplies centralized multi-account access. The two-way trust allows it, through AWS-managed Microsoft AD, to read and authenticate the existing on-premises users and groups without moving identity administration to AWS. Now consider why the remaining options are unsuitable. A. Migrating the identities violates the requirement to continue managing them in the existing directory. B. A directory trust alone does not create multi-account single sign-on assignments. D. A self-managed IDP on EC2 adds unnecessary infrastructure and identity operations. Keep this examination point in mind. Use IAM Identity Center with a two-way Active Directory trust when workforce identities must remain on premises. Question number 485. Question number 485. A high-volume API will use an Aurora PostgreSQL serverless v2 database. Forecasts show that database reads and writes will generate substantial input-output activity, and the company wants predictable, cost-efficient storage pricing as traffic grows. Which Aurora storage configuration should be selected? Option A. General Purpose SSD Storage. Option B. Aurora Input-Output Optimized. Option C. Provisioned IOPS SSD Storage. Option D. Aurora Standard. The best answer is B. Aurora Input-Output Optimized. The reasoning is as follows. Aurora Input-Output Optimized eliminates separate read and write input-output request charges, making it suitable for an input-output intensive Aurora workload whose traffic is expected to grow. The other choices do not satisfy the requirement because A. General Purpose is an RDS storage type rather than an Aurora cluster storage configuration. C. Provisioned IOPS is also an RDS storage type, not an Aurora storage option. D. Aurora Standard charges for database input-output and can be more expensive when input-output forms a large share of workload cost. The key takeaway is choose Aurora Input-Output Optimized when heavy database input-output would otherwise be a significant cost driver. The next key item is question number 486. Question number 486. Field crews around the world send live video to a regional ingest service by using a TCP-based streaming protocol. The company needs static global entry points and wants traffic to enter the AWS South network close to each crew so that stream quality is less affected by internet path variability. Which service should the company use? Option A, AWS Global Accelerator. Option B, Amazon CloudFront. Option C, AWS Client VPN. Option D, Elastic IP addresses attached directly to the regional EC2 instances. The required response is A, AWS Global Accelerator. The requirement is satisfied because Global Accelerator provides static anycast addresses, accepts TCP traffic at nearby edge locations, and carries it across the AWS global network to healthy regional endpoints. B, CloudFront is optimized for HTTP and HTTPS content delivery and is not the appropriate TCP ingest accelerator. C, Client VPN provides remote private access rather than global application acceleration. D, Elastic IP addresses are stable but do not optimize the end-to-end network path. Exam tip. Use Global Accelerator for latency-sensitive global TCP or UDP applications. Proceed to question number 487. Question number 487. A public HTTPS service must route requests to different backend target groups according to a query string value, such as model equals standard or model equals advanced. The company also wants AWS to manage the TLS certificate. Which load balancing solution meets the requirements? Option A. Use a network load balancer with an ACM certificate and configure query string listener conditions. Option B. Use a gateway load balancer with an imported IAM certificate and HTTP path rules. Option C. Use a network load balancer with an IAM server certificate and query parameter forwarding rules. Option D. Use an application load balancer with an ACM certificate and listener rules that evaluate query string conditions. The correct answer is D. Use an application load balancer with an ACM certificate and listener rules that evaluate query string conditions. An application load balancer supports TLS termination with ACM certificates and Layer 7 listener conditions based on query string key value pairs. The incorrect choices fail for the following reasons. A. A network load balancer operates at Layer 4 and cannot evaluate query strings. B. A gateway load balancer is intended for virtual network appliances, not HTTP application routing. C. Changing the certificate source does not give an NLB Layer 7 routing capabilities. Select an ALB when HTTPS requests must be routed by host, path, header, method, or query string. Evaluate question number 488. Against every requirement. Question number 488. A professional networking platform stores millions of member profiles and tens of millions of relationships. The application must quickly discover shared contacts and relationship paths that can be up to 5 hops deep. Which data store design is most appropriate? Option A. Store the data in Amazon RDS tables and use a sequence of recursive SQL joins for every relationship search. Option B. Store Parquet files in Amazon S3 and use Amazon Athena joins for each interactive traversal. Option C. Represent profiles as vertices and relationships as edges in Amazon Neptune and use graph traversal queries. Option D. Store the files in Amazon S3 and use Amazon QuickSight to calculate the relationship paths. The correct answer is C. Represent profiles as vertices and relationships as edges in Amazon Neptune and use graph traversal queries. The key reason is Amazon Neptune is purpose-built for connected data and can traverse vertices and edges efficiently across multiple relationship levels. The remaining options are incorrect because A. Deep, repeated relational joins are less efficient and harder to model for this graph access pattern. B. Athena is designed for analytical SQL over S3, not low-latency interactive graph traversal. D. QuickSight visualizes prepared data, but is not a graph database or traversal engine. A useful examination rule is this. Use a graph database when the primary access pattern is multi-hop traversal across highly connected data. We will now analyze question number 489. Question number 489. A company needs to replicate historical records and continuing updates from Salesforce into Amazon Redshift. The integration must use a managed, low-code service, and supported data transfer calls must remain on private AWS networking instead of the public internet. Which solution should be implemented? Option A. Create a direct connect circuit to Salesforce and use AWS Glue Databrew to ingest the records. Option B. Configure an Amazon AppFlow Salesforce connection that uses AWS Private Link and create flows that deliver the data to Amazon Redshift. Option C. Peer the Analytics VPC directly with Salesforce and run Amazon AppFlow over the peering connection. Option D. Create a site-to-site VPN to Salesforce and use AWS Glue Databrew for change replication. The appropriate choice is B. Configure an Amazon AppFlow Salesforce connection that uses AWS Private Link and create flows that deliver the data to Amazon Redshift. This is correct because Amazon AppFlow provides managed Salesforce data ingestion with scheduled and event-driven flows, and its supported private link mode keeps Salesforce transfer calls on private AWS infrastructure. The alternatives can be eliminated because A. A customer cannot establish a standard direct connect circuit directly to the Salesforce SaaS service, and Databrew is not the ingestion connector. C. VPC peering connects VPCs and cannot directly peer a customer VPC with Salesforce. D. Databrew prepares data, but does not provide this managed Salesforce change ingestion workflow. Remember this distinction for the exam. Use AppFlow for low-code SaaS transfers and enable Private Link when the connector supports private flows. The next item is question number 490. Question number 490. A regulated enterprise has hundreds of accounts in one AWS organization. Auditors require current evidence showing whether implemented AWS controls conform to frameworks such as PCI DSS and NIST. The security team wants one account to administer and view the findings across all member accounts. Which solution meets the requirement? Option A. Delegate AWS Security Hub administration to a security account, enable it for the organization, and enable the required security standards. Option B. Create an organization trail in CloudTrail and enable NIST and PCI DSS standards on the trail. Option C. Delegate Amazon Inspector administration and enable NIST and PCI DSS compliance standards in Inspector. Option D. Delegate Guard Duty administration and enable NIST and PCI DSS standards in Guard Duty. In this case, select A. Delegate AWS Security Hub administration to a security account, enable it for the organization, and enable the required security standards. Here is the technical justification. Security Hub can aggregate findings and evaluate supported controls across organization accounts against enabled security standards, producing centralized compliance status for auditors. Now consider why the remaining options are unsuitable. B. CloudTrail records account activity, but does not evaluate resources against compliance framework controls. C. Inspector identifies software vulnerabilities and exposure. It is not the service for organization-wide framework control assessment. D. Guard Duty detects threats, but does not run PCI DSS or NIST control standards. Keep this examination point in mind. Use Security Hub to centrally assess multi-account AWS resources against supported security standards. Question number 491. Question number 491. A media archive contains billions of S3 objects. Access patterns change unpredictably as different teams and applications use the data, but frequently accessed objects must remain immediately available. The company wants automated storage cost optimization without custom analysis. Which solution is most operationally efficient? Option A. Place all objects in S3 Glacier Flexible Retrieval and use S3 Select for every read. Option B. Move all objects to S3 Standard IA and invoke a Lambda function to return an object to S3 Standard after it is requested. Option C. Apply an S3 lifecycle rule that transitions the objects to S3 intelligent tiering. Option D. Use S3 storage class analysis to move every object to S3 Standard IA on a fixed schedule. The best answer is C. Apply an S3 lifecycle rule that transitions the objects to S3 intelligent tiering. The reasoning is as follows. S3 intelligent tiering monitors access and automatically moves eligible objects among cost-optimized tiers while preserving millisecond access in its frequent and infrequent access tiers. The other choices do not satisfy the requirement because A. Glacier flexible retrieval requires restoration and does not make every object immediately available. B. The custom workflow adds operations and cannot change the class before the triggering access. D. A fixed standard IA policy can create retrieval charges when objects later become hot. The key takeaway is use S3 intelligent tiering when access frequency is unknown or changes over time. Let us work through question number 492. Question number 492. A branch network needs an encrypted connection to a VPC. The expected traffic volume is small, high bandwidth is unnecessary, and the connection must be available quickly at low cost. Which option best fits the requirement? Option A. Deploy AWS Direct Connect. Option B. Configure an AWS site-to-site VPN. Option C. Run a Bastion host on Amazon EC2. Option D. Deploy AWS Client VPN for the branch routers. The required response is B. Configure an AWS site-to-site VPN. The requirement is satisfied because a site-to-site VPN creates an encrypted network-to-network tunnel over the internet and can be provisioned quickly without the lead time or cost of a dedicated circuit. A. Direct Connect is more expensive and normally takes longer to provision. C. A Bastion host supports administrative sessions rather than connecting two networks. D. Client VPN is designed for individual remote clients, not site-to-site network connectivity. Exam tip. Choose site-to-site VPN for quick, encrypted hybrid connectivity with modest bandwidth needs. Now consider question number 493. Question number 493. An organization is replacing an on-premises SFTP platform with a managed AWS service backed by Amazon S3. Employees must continue signing in with credentials stored in the existing on-premises Microsoft Active Directory, and the company wants minimal server administration. Which architecture meets the requirements? Option A. Create an AWS Transfer Family SFTP server that uses AWS Directory Service as the identity provider. Configure AD connector to reach the on-premises directory. Option B. Run an SFTP server fleet in an EC2 auto-scaling group and join each instance directly to the on-premises domain. Option C. Deploy an S3 file gateway with SMB shares authenticated by the existing Active Directory. Option D. Create a Transfer Family SFTP server and configure it to contact the on-premises domain directly without a supported directory service directory. The required response is A. Create an AWS Transfer Family SFTP server that uses AWS Directory Service as the identity provider. Configure AD connector to reach the on-premises directory. AWS Transfer Family supplies the managed SFTP endpoint and stores files in S3. AD connector allows the directory service identity provider integration to authenticate users against the existing on-premises directory. The incorrect choices fail for the following reasons. B. The EC2 fleet requires operating system patching, scaling, and high availability management. C. File gateway exposes SMB or NFS file shares rather than SFTP. D. Transfer Family requires a supported directory service or custom identity provider integration. It does not directly bind to the external directory in that manner. Use Transfer Family with directory service integration to retain SFTP and existing Active Directory credentials. Proceed to question number 494. Question number 494. After an invoice-created event is published, several independent Lambda functions perform idempotent checks. Each check needs only selected fields from the event. The company wants the producer and consumers to remain loosely coupled and does not want a custom routing function. Which solution meets the requirements? Option A. Publish the event to one SQSQ and use a coordinator Lambda function to synchronously invoke every validation function with custom payloads. Option B. Create one SQ per check and write a routing Lambda function that creates a different message for each queue. Option C. Publish the event to an SNS topic, subscribe all validation functions, and rely on message filtering to remove unneeded fields from each delivered payload. Option D. Publish the event to an event bridge event bus. Create a rule for each check and use an input transformer to pass only the required fields to its Lambda target. The correct answer. We will now analyze question number 495. Question number 495. A factory network has no internet route and is connected to AWS through Direct Connect. An on-premises application needs to call the public Amazon S3 service endpoints, and the company wants the lowest cost architecture using the existing connection. Which solution should be used? Option A. Create a VPC, deploy a NAT gateway, and route the on-premises S3 requests through the NAT gateway. Option B. Create a public virtual interface on the Direct Connect connection and advertise the appropriate public AWS routes. Option C. Create an S3 interface VPC endpoint and route all on-premises requests through the endpoint. Option D. Create a VPC peering connection between the on-premises network and the Direct Connect connection. The appropriate choice is B. Create a public virtual interface on the Direct Connect connection and advertise the appropriate public AWS routes. This is correct because a Direct Connect public VIF provides access to public AWS service prefixes, including Amazon S3 endpoints, over the existing dedicated connection without requiring direct internet access. The alternatives can be eliminated because A. NAT gateway introduces VPC infrastructure and processing charges. C. An S3 interface endpoint can provide private access but adds hourly and data processing costs. D. VPC peering connects VPCs and cannot peer an on-premises network with a Direct Connect connection. Remember this distinction for the exam. Use a Direct Connect public VIF when on-premises systems need AWS public service endpoints over Direct Connect. Now consider question number 496. Question number 496. A static web application runs in two AWS regions, with an independent regional load-balanced EC2 fleet in each region. DNS should return endpoints from both healthy regions and stop returning an endpoint when its regional application fails. Which choice meets these requirements? Option A. Use Route 53 simple routing with both regional endpoints in one record. Option B. Register EC2 instance IDs from both regions in one regional ALB target group. Option C. Register the public IP addresses from both regions in one regional ALB target group. Option D. Create Route 53 multi-value answer records for the regional endpoints and associate health checks with the records. In this case, select D. Create Route 53 multi-value answer records for the regional endpoints and associate health checks with the records. Here is the technical justification. Multi-value answer routing can return multiple records and suppress records whose associated health checks are unhealthy, providing DNS-level distribution and regional failure avoidance. Now consider why the remaining options are unsuitable. A. Simple routing does not use per-record health checks to return only healthy endpoints. B. An ALB target group cannot register EC2 instance IDs from a different region. C. A regional ALB is not a global router for arbitrary public IP targets in another region. Keep this examination point in mind. Use Route 53 health-aware routing when DNS must stop returning unhealthy regional endpoints. You have completed Part 14 of the SAA-C03 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.